Okay, y equals tangent x. We're going to start by graphing tangent x, sine x over cosine x.
No, like what you did, or so funny. You're so awkward because we're just like circling around.
Okay, let's see. Make sure everyone's graph is the same before we continue. Okay, all right, so let's look at this graph and let's ask ourselves, is the inverse tangent a function? Huh? Yes?
Is it inverse?
If you do a horizontal line test, will it go through multiple points? Yes, so it's not a function. So same thing as before, we're going to have to limit it between two numbers so that it will work. And this one actually is the same idea as sine. So we're going to limit it between negative pi over 2 to pi over 2. So between negative pi over 2 to pi over 2. The only difference between this one and the sine, inverse sine graph is negative pi over 2 and pi over 2, there are asymptotes. So the asymptotes are going to carry from the function to the inverse function. But let's go ahead and write down our points first before we graph the inverse tangent function. So on this bottom left corner point, what is the coordinate? What is the x coordinate of that? Very close. Negative pi over 4. Okay, what is the y coordinate? Yeah, negative 1. Okay, and then we have here 0, 0. And then the top right point, what is the x coordinate? Pi over 4, comma 1, correct. Okay, so now we're going to graph the inverse function. We're going to have to switch x and y on everything. The x and y coordinate switches, and then the x. Okay, so x and y coordinates are also, our axes are also going to switch. So we're going to look at the inverse tangent. Okay, 1, negative 1, and let's do negative pi over 4, negative pi over 2, and we're going to do the top as well. Okay, so we're going to switch x and y and regraph this. So the bottom left point is negative pi over 4 and pi negative 1, so that switches, and we get negative 1, negative pi over 4. Yeah, it kind of looks the same as the sine graph, but I'll show you later that it's going to be different. Okay, 0, 0 is 0, 0. And then the top right-hand corner one, pi over 4, 1. So that switches. You get 1 pi over 4. Okay, along with that, the asymptotes are going to come with us as well. So in the original graph, where are the asymptotes? Yeah, negative pi over 2 and pi over 2. And they were vertical, right? So when you switch it to the inverse function, yeah, they're going to be horizontal. So we have our asymptotes. All right, and then the inverse function is going to flip over that line. So this inverse function becomes this shape. And it goes on forever because it's trying to get to the asymptotes. All right, next, on the unit circle. So you can see that it's going to be from negative pi over 2 to pi over 2, which is going to be on the right-hand side. But it's going to be a little different because we cannot include negative pi over 2 and pi over 2. So I'm going to put 2 circles there to tell you that those 2 numbers don't exist. Okay, so the cancellation law is the same thing from yesterday. We can cancel this only if x is what? Yeah, that is an angle, and the angle has to be between what? Negative pi over 2? 2 pi over 2, but we don't include either one because there are asymptotes on those 2 values. What about this x? What numbers can go in there? What do you guys think? Not -1. No. Values go in here, so not an angle, but what values? Yes, all real numbers. All right, let's practice. First one, inverse tangents of square root 3. Tangent of what is square root 3? Tangent of what is square root 3? So you're going to have to think about, either you memorize all your tangents. That will make things a lot faster. Or then you have to think about sine over cosine. So whichever way you prefer. Okay, so you got to think, what angle makes sine over cosine a square root 3? So that means sine has to be square root 3 over 2 and cosine has to be 1/2. This is the only way that you're going to cancel and get square root 3. So what angle makes that happen? Sorry, you've been trying to tell me pi over 3. Okay, so that means sine has to be the longer one. So either here or here, because they have to have the same sign in order to get a positive number. So either both positive or both negative. Yeah, but inverse tangent is just like inverse sine, only on the right-hand side. So only pi over 3 will work. Good? Not good. Tangent for pi over 4 is 1 because at pi over 4, sine and cosine have the same ratio. Yes. Okay, so then number 2, inverse tangent of 1. When is tangent of what angle gives me 1? Or when is sine and cosine the same ratio? Yes, pi over 4. Okay, all right. Let me ask you a question before I let you go do this on your own. Give me a thumbs up. You're like, I think I can figure this out by myself and I'm okay. You have a... okay, sideways thumb, like, I can't really get started if you don't help me. Like downward thumb, like I don't have any idea what has been happening for 2 days. Okay, all right, let's help you get started on number 3. Inverse, so this is where you have a tangent and an inverse sine at the same time, or basically 2 functions at the same time. You're going to have to evaluate this first. Inverse sine 1/2. What angle gives sine 1/2? Pi over 6. So then we change that to pi over 6. Next, you just evaluate tangent of pi over 6. So unless you memorized it, you would... Too fast. Yes, good job memorizing that. So that's going to be sine pi over 6 over cosine pi over 6. So that's 1/2 over square root 3 over 2. And you got to do some work there. 1/2 times 2 over square root 3. That's 1 over root 3. If you want to rationalize it, you can. Then you get root 3 over 3. Okay, I'm going to let you do the rest with your partner. All right, 2 pi over 3. So tangent 2 pi over 3 is going to be negative square root 3. Negative square root 3 is about negative 1.7, or basically it's bigger than 1 or less than negative 1, so this is no solution. Okay, let's see. Any question on this one? You okay or not okay? Explain.
Why is it negative instead of positive?
Yeah, why is it negative?
Why is it negative? Okay. Okay, so tangent of that is sine of 2 pi over 3 over cosine of 2 pi over 3. So at 2 pi over 3, that is right here. Sine is square root 3 over 2, but cosine is negative 1/2. So then this becomes negative square root 3. Okay, next one. All right, we gotta use the calculator. Oh, and this is in degrees and radian. All right, so just practicing, making sure that you know how to switch between the modes in your calculator. So your calculator is stuck inside inverse function. So that's why your calculator will only give you one answer instead of multiple answers, because it's a function. So it will only give you one answer. Or else your calculator will give you tons of answers and it makes no sense. Okay, so first, arc sine negative 0.81. So what is this? A value or an angle? Value. Okay, so then you want your answer in degrees and radian. So let's do degrees first. So you just want to change the mode to degrees in your calculator. And then find your inverse sine function. So second sine. And then you want to type in negative 0.81. Negative is the very bottom button, not the minus sign. If you use minus sign, your calculator will say error. If you have any trouble, please let me know. And make sure you know how to use it before the test. Okay, what is the answer in degrees? Yes. Okay, now try the same thing in radian. Okay, I'm going to show you some calculator shortcuts. So since you already put in inverse sine of negative 0.81, there's no need to type that same thing in again. You can tell your calculator to just recall the previous entry. Just press second and then the equal sign, because on top of equal sign is this entry. It will recall the previous one. If the previous one is not the one you want, you can keep pressing that and it will keep going back of however long your calculator was saving the memory. And then you can just use that instead of typing it in every single time. Okay, what's the answer in radian? Okay, 0.94 radian. All right. You guys feel pretty good? Oh. Yeah. Okay, then we gotta try to fix that. Okay, so go ahead and do 2, 3, 4. Number 2, 1.53 radian, or 87.49 degrees. Number 3, 2.59 radian, or 148.54 degrees. Number 4, 1.80 radian, or 103.3 degrees. Okay, so on your test and things like that, make sure you have a degree sign. If you don't have a degree sign, I'm going to assume you meant radian. Okay. Please be careful. Let me see. Okay, that's it. So you have a lot of time to do homework, so go ahead and get started.